6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome out there to TN Learn Mathline Summer School Style. We're so glad to have you tuned in this afternoon. I'm your host, Ernie Roberts, and we're going to be sitting back, relaxing, doing some math today. I don't know how much you're going to need a calculator. You might want to have some pencil and paper out there as we work together. Problems, we're doing review, we're remediating, we're going back to some real basics this week and through this session. So keep in mind on that. Some of it may seem easy. No, it's always good to know what do you know and see what you know and what you need to remember. So let's take a look at what's going on here today, all right? Topic for TN Learn Mathline Summer School, ready, set, multiply. Let's do it. I'm ready, set, multiply. Are you guys? Let's do it, all right? Let's see what our first problem is going to be all about. Looks like we're looking at applications today. George with 11 dimes, what is the value in dollars and cents? Now, that sounds simple enough, and it is. It really is. And even if you know a few other little clues, it even makes it more simple, right? Because we know about money. We think money. We work with money. It's something we can touch. It's a great application. It's real world. So, as we look at 11 dimes, we know each dime is worth 10 cents. At least I hope you do. If not, you just learned a new fact here on Mathline. Each dime you have in your pocket or in your possession will be worth 10 cents. So what are we going to do with this? The whole idea says, remember, ready, set, multiply. So let's do just that. It's ready, there it is. We're set, let's multiply. So we got 11, and I mentioned that we have 10 cents, and I'm going to make a decimal out of that, all right? I'm going to make a decimal there for 10 cents. And remember when we multiply, we have to count to the right how many decimal places? Well, let's go ahead and multiply what 11 times 10 gives us. It gives us 110. And if we're talking money, we have 110. By the way, remember I said cents? Let's go ahead and do that part while we're at it. That's what we have by itself. Let's just get rid of that decimal for a minute, all right? But when we take care and bring the decimal in, oh my goodness, that's where we have $1.10, all right? So there's your dollar and cents. That'll be $1.10 working for you right there. Boy, that's an interesting looking dollar mark, isn't it? Now, question again, it's all about multiplication. Now, why did I have two decimal places? Because that's what I have in the 10 here, all right? So, Ernie, could we use 1/10? Right, but remember, this is like 10 cents per dime, all right? So that's why I chose to use the decimal in the 10 there. And in money, that's how we address it, $1.10. Or 1 and 10, all right? So that gets us started a little bit. That's what we're about today. We're going to look at applications, and with those applications, we're going to have a good time. Some will be money, but most of them try to make a little bit of real-world aspects for you, all right? Let's take a look at our next problem. Let's see what we got here. I have 1 cup of flour that will make a dozen cookies. Woohoo! That's a lot of cookies, folks. A lot of good eating. And how many cookies can 8 cups of flour make? All right, now, key words here as we get set ready. Let's look at this first. We got the word dozen. Dozen, of course, means 12. 12 cookies. That's why I said that's some good eating, all right? We have 1 cup of flour making 12 dozen cookies. We're going to up that amount to 8. 8 times as much as we started with, all right? 8 times the number of cups. That means 8 times the dozen. We're going to be ready to multiply, all right? So let's do that. Let's take 8. We're going to take it times our 12 right there. And you know what that's going to give us? 8 times 12 gives us, you got it out there, you know the times table, right? No decimals allowed here, no problem. It's just multiplication. Woo! 96 cookies. You say, Ernie, where'd you get the 96? Where'd you get the 12? Remember, a dozen. 1 cup for a dozen. So what I'm going to do is 8 cups. So I've got to multiply by 8. 8 times the 12. How many are in a dozen? And that gives me 96 cookies. And folks, I'll tell you something. It makes me hungry. And it is right about dinner time for many of us as we watch this, all right? So have some cookies. You deserve it. You've been good today, right? Right on. So ready, set, multiply. That's what we're doing. So we're going to read. We're going to basically get set with what we're going to do, and then we're going to just do it. We're going to carry it out. We'll do the multiplication, and most of it is all about multiplication today, all right? So let's see our next problem. Next problem here. It says, which is greater, 7/12 or 2/3? Now, looking at that, I have sometimes students, and I know when we're just first learning our fractions, a lot of you younger folks out there, some of you older folks too sometimes get a little concerned and worried and wondering, which of these is greater? And a lot of people say, well, I see 7 and 12, they're bigger numbers, so we'll say it's greater. It's a 50-50 shot, right, to guess. That would be the wrong guess on this one. I'm going to go ahead and tell you 2/3 is going to win out. But let's see why. Let's see why. It's not about the numbers that you see. It's basically about when we can compare these fractions. When we compare these fractions, we need to have the same number in the denominator. All right, so now I'm going to look at something here. We've talked about multiplication. You say, well, Ernie, what's multiplication got to do with this? Well, one thing, I'm going to multiply this 3 times something to get 12. That would work because I need a 4 there. Also, some of you didn't see that little point coming. You could go ahead and multiply 3 times 12 and 12 times 3. It'll give you a common denominator. It's just not the least. In fact, let's do that first, and then we'll come back and do it the other way. And how about it? 12 times 3 and 7 times 3. And remember, whatever we do to the denominator, we got to do the numerator. So I'm seeing 36 popping up down here. 36 over here. And while that's happening there, I am also seeing that we need to adjust some things here, all right? Now, over here, we multiply by 3. Over here, we're going to have to multiply by 12. By 12. And remember, if we do it to the numerator or if we do it to the denominator, hey, we got to do them both, all right? So we took care of the denominator first. Now we've got to multiply that 12 into the numerator so they get equal treatment. Now, on the left-hand side, I have 21, because that's what 7 times 3 gives us, right? You know those times tables. 2 times 12, we're going, a lot of multiplying going on here. We got 24. Well, I'll be, looky there, folks. 2/3 does win out. It does win out because 24 is greater than 21. Or you can say 21 is less than 24. All right, and that's what that symbol, by the way, is a less than. So it tells me this side is the smaller and this one is the winner. Ding, ding, ding. So 2/3 is our winner. Now, I mentioned something about multiplying by 4, and some of you go like, what was that about? Let's go back to the fractions again. We'll draw a little line right down through here. And let's see. We have 7/12, and we have that 2/3. Just want to do a different moment with it, all right? This time, I'm going to leave 7/12 as it is. But I'm going to multiply this 3 by 4 over here, which means, guess what? Yes, we've got to multiply the numerator by 4 also. And look what happens. I get 7/12 and I get 8/12. The story, the ending, the story is still the same. Now, how we get there is a little bit different. But the ending is still the same. This first fraction, 7/12, was smaller than 2/3. And by the way, these would reduce right down to those numbers also if you were trying to reduce them. But again, the question says, which is greater? So, looks like it's here, and it's still 2/3, all right? So 2 ways to work that problem and get the correct answer and get the correct decision. It's not a 50-50 chance, especially if you know how to work the problem. It's a 100% chance you're going to get it right. Correct out there, everybody? Everybody with me? Let's have some fun. Get ready, set. Let's multiply again. Let's check out a new problem here. Kimbrough bought a pair of socks for $8. How much money would 7 pairs cost him? All right, so how much is he going to spend here? Kimbrough, let's see. Sounds like a multiplication deal to me. Now, a pair of socks, by the way, folks, pair does not mean we have to multiply 2 into this problem, all right? It says every pair is worth $8. We're going to have 7 pairs. So it's simple, very easy. If you know the multiplication table, this one's very easy. Take your 7 times your 8, and that will give you, by the way, what are we talking about? Not socks, not buying 56 socks. We're actually going what? We're going for 56 dollars here. That's what we're talking about. How much money? So basically, we're multiplying by $8 right there. I'll put that in there. So 7 times 8, that's where we get the 60. Not the 60, the 56. I was going to say, make that dollar sign a little bit better. That looks kind of crazy, doesn't it? But it's 7 times $8, get you $56, and there's your final resting point. Someone says, well, Ernie, could we have said 8 times 7? Certainly. 8 times 7 would also get you where you're going. Commutative property, still be $56. You don't save any money by doing it that way, but it still works. Get you the right answer. Now, friend Ethan over here decided he was going to buy a different situation. His socks were worth $7. All right, so how much would buying 9 pairs cost him? So let's take that $7. I'm going to do that dollars first because that looks a lot nicer, doesn't it? And times our 9. And again, times tables, folks. What is 7 times 9? You can do this in the store. If you're looking for your items that you're trying to buy, figuring out how much you're going to be. It looks like $63. Now, they may tax you a little bit on that. They probably will, unless tax was included on that $7, which most of the time it is not. All right, most of the time they tack it on later. Now, we could have also run it 9 times, as I said a little bit earlier, that commutative property wows and zows us there, and we would have $63 too. So many times do we think of different ways to work through it. Now, I want you to know the times tables. But if you got in the store and you're going like, oh man, all right, I'm going to buy 4 pairs. You can count 7, 14, 21, 28. You could do that, $7 each to get your money. You can count all the way up to 9. But it's so much easier, isn't it, just to hit that multiplication in your head and be done. And know you're right. Know you're right. That's what's important. So this was the ready, set, got to multiply. Got to multiply. It's the best way to do it, all right? So you've seen socks. We've seen a little bit about change. Let's look at some measurement situations here, all right? Let's look at this situation, thinking about which is the longer measure, all right? 80 inches or 7 feet. Now, you look at 80 inches and you think, that's a nice round number. But when you start to divide 12 into that, ooh, doesn't quite work out. However, you do notice one thing, since we're just asking which is longer, you do know it doesn't quite get to 7 feet there, or does it? Because we need to know what 7 feet is. And how do we figure that? Well, let's go there first, all right? So we're going to take and change the feet to inches. That's our set in mind, okay? We're ready. We know the problem. Let's set it and let's multiply. Notice I said multiply. I didn't say about dividing. So let's leave 80 over here by itself for just a little bit. But let's go over here and say 7 feet. And we're going to take that times 12 inches per foot. Because that's a transition. That's our conversion moment here. Now, like I said, for those of you who are purists about this, we'll lose the feet right there. They cancel out. And it looks like we're going to say 7 times 12 inches. Some of you say, I would have done it to begin with. That works fine for me, all right? Just want to show you why we do multiply 7 times 12. And that would give us, we know our times tables, 84 inches. So you can compare pretty easily now. 84 inches is obviously less than 84. So 7 feet is the longer measure on this. So we know our times tables. We know 12 inches in a foot, by the way. That's the main conversion factor. And then we multiply. So easy, isn't it? If you know how to multiply, it's great. It's great to know those facts. Great to know those facts and not have to worry too much. All right, let's do a little twist here. We'll talk about a square. Now, think about a square. Yes, all 4 sides are the same length. They're all the same length. So what I want to know is the length of a side if I know the area. Well, basically what this is telling me is something times itself equals 121. And by the way, they're going to be feet because we're talking about square feet out here. All right? So what do we do? Think of numbers. Think of your times tables. Think of numbers times themselves. And where you hopefully eventually come to, you're thinking about, okay, it's got to be over, well, it's over 100, so it's got to be bigger than 10 and 10, and we'll try 11 times 11. Let's see what happens with 11 times 11. You know your times tables, right? It's exactly what we're looking for, is 121. Now, what if I'd said 144 square feet? Guess what? You would have used 12. 12 times 12, because again, you know that combination. Now, just a little aside here, we're just talking about multiplication tables pretty much today. But if you are in my geometry classes or in my algebra 1, 2 classes and trig classes and such, I want you to know what times itself goes all the way up to 400. Now, I don't want to know 400 times 400, no. But I want you to know that 20 times 20 gives you 400. That's easy. But I want you to know all those other numbers. What's 13 times 13? 14 times 14? 15 times 15? That's another little endeavor to get into your head up there. Some more multiplication numbers that are great to know. But for right now today, we're all about 11 times 11, 12 times 12. Won't go any higher than that for right now, okay? But nonetheless, those squaring numbers are so important to know, because there's this crazy thing called Pythagorean theorem and a little bit of things called right triangle trig that it's nice to know. It's nice to know those relationships between those numbers on up to 20. Now, let's take another look at a problem. We've been talking applications today. Let's take a look at a money problem here. It says Juan Carlos has 12 $5 bills and 15 $10 bills in his cash box. What's the total value of his money in the box? All right. So this is a two-part question. Let's think about it. Important right here. You got $5 bills. You got 12 of them. You're going to be multiplying to figure out how much those dollar bills are worth altogether. Now you've also got 15 $10 bills. And in the end, we're going to find a total. So this is really a setup, and let's get it set up before we get multiplying and all those good things. Let's take it one step at a time, all right? So how about it? $5 times 12 of those, okay? So $5 bills times 12. Next thing, we're going to add that to, 15 times 10. Go ahead and put a little X there since I've been using the times sign a lot this week. And there's our plus right in between. We are going to figure out, you could have put a dot there, right, for multiplication, all right? So that's 15 times what? There's the $10 bill, right? So there we go. That's $10. So let's think about it. 5 times 12, you got that times table down, right? You can see it real quickly. If you didn't, you can look at that and multiply it in your head, I believe. That's $60 right there. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. There's 12, 60, all right? Now over here we go 10, 20, 30, 40, but you know what? It's really easy to multiply by 10 because all we need to do is put the 15 down and add the 0 right there. So that's $150. We're adding it all together. Right there you go. And 60 plus 150, how about it? 210, and we're talking money, dollars, all right? So again, a lot of things you can do mentally, and money makes it real easy. You're thinking about counting by 5s, by 10s, money makes it work, but also multiplication. It's easy to work back to that too, all right? So, money, squares, cookies, all sorts of good things today here on TN Learn Mathline. Let's see what our next storyline is, okay? Let's take a look at this one. It says a rectangle has length of 12 meters and a width of 8 meters. Now again, that's a rectangle. Now that's a little wider in this case. It's actually a little longer. Let's go back to that point. It's longer by 12, and then we're going down width by 8. We usually tend to think about that. Of course, they come back together, but it's a nice little rectangle. All right, so we bring it out 12 meters and by 8. To find area, there's a little formula. It's another thing that's helpful. It's take the length times the width. All right, take the length times the width. So here we go. We're going to use the numbers, 12 meters, and we're going to multiply that by 8 meters. Length was 12 meters, 8 meters. And you say, what are we going to do, Ernie? We're going to get, looks like, how about it? 96, and we're going to have meters, and you know what we're going to do? We're going to get meters squared, or we can call that in nice words, 96 square meters. So M standing for meters, all right? And so there we go. It's basically an M times an M. By the way, when we take a variable times a variable, it's that variable squared, whatever it happens to be. If it's X times X, it's X squared. If it's M times M, it's M squared. But we're going to go ahead and use that as square meters because that's the units of measure that we're doing. We're talking about the space inside that rectangle, And again, easy, so easy if you know what 12 times 8 is off the top of your head. Oh yeah, you can go to the calculator, but it takes time. It takes punching, and sometimes you miss punch. Your brain doesn't miss punch once it learns that fact. 12 times 8. Might forget it a little bit. Hopefully it got it back, but 96, that's where we're going on that one today. So area of a rectangle, area of the square, all those things are good, important beings for us. Now, we've talked about fractions a little bit. Let's take another look at fraction type problems here, all right? Let's take a look at this problem here. It says we're going to subtract the two fractions. We got 7/12, and we're going to subtract 5/6 from there, okay? 12 12 minus 5/6. Now, some of you are thinking, wonder which of those is larger. 7/12. Now 7 and 12 are bigger numbers. And there's that 5/6 coming up. And you know, some of you got fooled a minute ago when we had, what was it, 7/12 and 2/3. Well, we need to figure this out. Because you said, well, Ernie, can we do that? Oh yeah, we can subtract this. We can subtract this irregardless of which one's larger. But we just need to be aware something could be going on. Now, I'm going to do two things. I'm going to do two different ways. I'm going to make it a little more complicated at first. Since we've been talking about multiplication, I really want us to figure out what 6 times 12 is one time. You know, how can you relate 6 and 12 together when you multiply? Well, remember, 12 inches in a foot, 6 feet would be how many inches? Let's multiply and find out. 6 times 12, that's what I'm going to use first of all for my common denominator. Notice I said common denominator. I didn't say least. Did not say least common denominator. We'll work it again over here with the least common denominator. But let's put a 72 in here right now. Because that's what 6 times 12 gives us, all right? That's what 6 times 12 gives us, all right? Now, let's take a look at this creature here. It goes in there 6 times, right? Because that's what 6 times 12 gave us. So we're going to multiply that 7 in the numerator by 6 also, which is going to be 42. 42, all right? Know those times tables, like I say. Over here, we're going to take it times 12. And you know what? We're going to multiply by 12 in the top also. We're going to have minus, 60. Because that's what 5 times 12 is. Think about it. 12 $5 bills. You got it. Right? Right? Easy, easy? Of course it is. Of course it is. Yeah, yeah. Now, let's subtract. Let's subtract. 42 minus 60. You say, Ernie, 60 is bigger than 42. You're right. So we're going to still subtract 42 out of 60, but we're going to end up with a negative value. How about it? Negative 18 over 72. Now, some of you are thinking, I bet you're wanting us to think about this, aren't you, Ernie? That can certainly reduce. That can certainly simplify quite a bit, all right? Now you say, well, what's going to happen? I see 2. I see 3. My goodness, 6 will divide into that. So let's divide 6 into both of those and see what happens. 6 into 18 goes, looks like 6 goes into 18. That'll be 3. And 6 goes into 72. Oh, we know that. This goes 12. Because 6 times 12, we know that. We can still reduce one more time. Wow. This is going to, by the way, it's negative still. It didn't change. Negative 1/4. Would it come out if I had used a different common denominator? Because when we have to reduce that much, y'all can drop the bottom out just a little bit for me there. We've got the negative 1/4 here. That's what we're going to hopefully end up here. So let's take 7/12 and let's subtract it as we see it. Now, we need a 12. And by the way, folks, 6 divides into 12 evenly, so that's a nice thing. That's a nice thing. So we'll just put a 12 there. This will make the numbers a lot smaller, and we still get 12s. That means we multiply by 2 here. We're going to multiply by 2 up here. So I've got 10. I've got 10 left over here, all right? So I've got 7 minus 10. 7 minus 10. Does everybody see the difference here? We've still got a common denominator. You've got to get a common denominator. Still about multiplication. But oh my goodness, are those not smaller numbers? So when you see a number like 6 will divide into 12 evenly, grab it and go. Much less opportunity to make mistakes. Now, yeah, 72, we can work it out. But boy, it was a lot harder, wasn't it? So let's put it over here. We got negative 3 over 12. And guess what? That's starting to look alike, isn't it? Starting to look very similar. That ends up with negative 1/4. And you know, we got it both ways. Which way was easier? Definitely the one on the right. Smaller numbers in the denominator, smaller numbers in the numerators. Over here, I had to really be careful. All right? I had to really be careful because I was getting into big numbers. But you know what? If you knew your times tables, you can work that out. You can divide it out. You reduce it out. And life was good. All right. Speaking of life being good, we hope you've enjoyed a little remediation time today on your multiplication tables. A little bit of fraction action there. We're going to take a lot more fraction look in another week or so here on summer school. Also, we're going to compare those fractions like we did earlier. But don't forget areas, times tables, all those great things. And you know what? When you know those, life is a lot easier in the world of math. Hey, thank you for tuning in today. We hope to see you once again next time.